Alright, welcome back to 20.1 Conditional Probability. We're going to go over Explain 1 using conditional probability formula. So here, I pulled this from your textbook. It says the conditional probability of A given B, so that is the probability of an event A occurs given that event B is occurring, can be found by this symbol, by the way. That's what conditional would mean. By figuring out what both events would happen, so what they have in common, divided by the probability of B only happening. Okay, so let's work out a couple problems and see how they do this. So let's say, for example, I have a standard deck of cards, and there's a picture right there on your worksheet as well. For a standard deck of playing cards, find the probability that a red card randomly selected as drawn from a deck is also a jack. So first of all, step 1. Let's find the probability of a red card. What letter do you want to use for red? R. And that's for, again, the probability of choosing that a red card is chosen. Okay, so let's work this out. What would be the probability of a red card? Well, there's about, in case you forgot, 52 cards in a standard deck. And how many of them are red? Well, that's 13 and 13, which would make a total of 26. All right. So it says find the number so that it's red. So that it's red. And that's a jack. What letter do you want to use for jack? Yes, and I could actually write this instead of R and J. I can write this as J and R, and that's the probability that a red jack is chosen. All right, so jack, that's red. So how many red jacks do you see out of the entire deck of 52? Well, I see one here and there. How many is that total? 2. Yes, there is. So, the probability of, for step 3, of a jack, given that we pulled a red card, is going to be our jack of R over R. So here that was 252 over 2652. So I'm just going to record this down for number 4 to simplify our result. It's going to feel like a lot of recopying, by the way, and I do apologize for that. That's J of R, so it's going to be JR, I'm just copying from here, R, and 2 over 52, 26 over 52. What, by the way, they both have the same denominator. What denominator is that? 52, right? So why don't we go ahead and multiply, just get rid of that, so that way it doesn't look like a fraction being divided by a fraction, which I know we can do on our decimals calculator, but we can simplify this out. So that would be 52's would cancel, and I'm left with 2 over 26. Without even using the calculator, let's go ahead and reduce. What number could I take out of both top and bottom? 2, right? So that'd be 1 over 13. Cool. Alright, let's move it right along to part B. Again, we're using this. Conditional probability. Alright, so for a standard deck of cards, this time, it kind of feels similar, but they're doing the first thing they're doing is pulling a jack at random. And let's say it's a red card. So it says, for step 1, find the probability of a jack being pulled. How many jacks are in that cards? Well, there's not only one heart and one diamond jack, there's also a club and a spade. So there's about 4 jacks out of the 52 cards we have available. Now let's go ahead and count up how many of those jacks are red jacks. Well, just like we found, there was only 2 that were red jacks, right? So here that would be for both Jack and Red would be 2 over 52, divided by all Jacks, just 4 out of 52. So let's go ahead and fill this in. Again, we're multiplying both by 52. Now, just in case you're wondering, well, what if my bottom number was 13? Then we can multiply by 13. What if my bottom number is 27? Well, then we can multiply both top and bottom by 27. This cancels out, and I'm left with 2 over 4. And we can reduce. They give us a hint that I guess you divide by 2 to both top and bottom, and that would be, got a way of getting that done. Just like it says here on the bottom of your page, stop and do the problems in your packet. We'll come back to go over the next problem, which I guess is 20.2. Oh, actually just the homework for 20.1. Awesome.